Hello all, welcome back. In this video we'll be discussing about binomial distribution. In essence, the binomial distribution or binomial events are a sequence of identical Bernoulli events which we discussed in our previous video. We use the letter big B, the capital B, to express binomial distribution followed by the number of trials and the probability of success in each trial. We can see here x is followed by the number of trials n and the probability of success on each trial. And for example, we have got 6 trials and the probability of success of each trial is 0.1667. And suppose we have n independent trials where the n is the fixed number, which may be 10, 1 or any number, and each trial can result in one of the two possible outcomes, and we're gonna label those outcomes as success and failure. Then the binomial experiment has 4 properties, like it consists of a sequence of n identical trials and 2 outcomes, success or failure, are possible on each trial, and the probability of success on any trial denoted by p doesn't change from trial to trial, and the trials are independent. So the probability of success on any individual trial is p. That is, suppose there are n independent trials and each trial can result in one of 2 possible outcomes labeled as success and failure. The probability of success on any individual trial is small p. That is, we can say that this p can be represented by probability of success. This big P of success is equal to small p, that has to stay constant from trial to trial in order for us to have the binomial distribution. And here we have only 2 possibilities, success and failure. So the probability of failure on any individual trial is simply 1 minus p, or probability of failure here. And because failure is just the complement of success, so the random variable x represents the count of success in n number of trials. So we can say here we are going to let this capital X to be the random variable representing the number of success in n trials. If all those conditions hold, then the random variable x, this capital X, has the binomial distribution where the probability that the random variable x, this capital X, takes on some little x, this small x, is equal to this formula, and this formula contains the combination formula, this nx, or this binomial coefficient, and more we can say this as the combination of n and x. This is the coefficient, and this is multiplied by p raised to the power x into 1 minus p raised to the power n minus x. And this whole formula is not the probability distribution until we actually say what values this formula works on. So we gonna say that is true for x is equal to 0, 1 up to n, and we're gonna have the success. This x, small x, represents the number of success which range from 0 to n. Suppose, let us see a simple example of binomial distribution. Suppose we have got a balanced 6-sided fair die which is rolled 3 times. So we will see what is the probability of 5 comes up exactly twice. So here what we can write is success is rolling a 5, and failure is everything that is not success. And if we let x represents the number of fives in three rows, then x has a binomial distribution with n is equal to 3 and p is equal to 1 by 6. The probability of success 1 by 6 remains constant from trial to trial, and knowing what happens on one roll, we don't know what happens on the next roll, so the trials are independent. So the condition of binomial distribution are satisfied here. So to find this probability, what we do is we just put these values into our binomial formula. Here, this is our binomial formula. The probability that random variable x takes on the value, this random variable x takes on the value 2 is equal to, here is our 3 and 2 successes, so 3 chooses 2 times, and here p is 1 by 6, the probability of success, which is raised to the number of success, which is 2, and we multiply that by the probability of failure, which is 1 minus p, and here 1 minus 1 by 6, which is raised to the and it is raised to failure, which is 3 minus 2, and after the calculation we get 0.0694. that is the probability of getting exactly 2 fives if we roll a fair die 3 times. So this is the simple example of the binomial distribution.